Welcome back. This is section 3.3 on the union of sets. The union of sets A and B includes all elements that belong to the set A or the set B or to both A and B. And we use the symbol which looks basically like a U. And the union of A and B is written A union B like that. So the shaded area A union B is actually all of this area here. Okay, that's A union B. And we can write it in this form. So element X, such that X is a member of A, or a member of B, or both A and B. Let's have an example. A equals 1, 2, 3, 5. Set B is 2, 3, 6, 7. Okay, if we made our Venn diagram, A and B here. Okay, we can see we have 2 and 3 as the common elements. So we put them in the intersection. And then we have 1 and 5 here. And B, we have 6 and 7 on this side. So A union B is all of the elements together. So 1, 2, 3, 5, 6, 7. And remember the intersection, A intersection B are only the common elements, 2 and 3. Let's look at an example. We have the universe, which are all numbers 1 to 10 that are natural numbers. And set A is 1, 2, 3, 4. Set B, 2, 4, 6, 8. Set C, 3, 4, 5, 6. So how about looking at this central part here? In here, are there any elements that are in all three sets? We can see we have element 4. Is there any more? No. So only element 4 goes in the middle because this is shared by all three sets. So we have element 1 in A, and 1 is only in A, so we'll put 1 there. What about 2? 2 is in B and A, so that needs to go in here. So it's shared between B and A, but not in C. Element 3 is in A and C, so we should put element 3 there. Element 4 is in all three sets. So element 6 is in B and C, so that must go here. Element 8 is in B only, write 8 there. Element 5 is in C only, so write 5 there. So what elements do you have? 1, 2, 3, 4, 5, 6, 8. Okay, remember the universe is all numbers between 1 and 10. So what are we missing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 3 elements we need to include, and they're not in any set. So we're going to have 7, 9, and 10 we can put there. Anywhere outside those 3 sets. So now we want to find A union B. So all the elements that are in A or B or both. So that would be these elements here. So we'll have 1, 2, 3, 4. 1, 2, 3, 4. 6, 8. Okay, so they're all the elements that are in A or B. A or C, A union C. So these elements here, 1, 2, 3, 4, 5, 6. Okay, so this one is B union C. So B union C are these elements here. 2, 3, 4, 5, 6, 8. Like that. So this is A union, not C. Let's do this bit by shading. So A, let's clear that out. So A is here. A union with not C. So everything that is not C, union. So not C, color around. Like that. So A was all the blue section, which was here, plus the green section. So everything that I colored in is part of the answer. So that's 1, 2, 3, 4. So 1, 2, 3, 4, 8, 7, 8, 9, 10. Like that. Now this one, part V, A intersecting not B. So A is here. Where does that touch not B? Okay, we're looking for intersection here. So where does it touch not B? If I colored in not B, there, where did those two colors touch? Only this section here, only these two. So your answer will be 1, 3. Okay, A union B union C. What that basically means is all of your sets put together. So all of the numbers inside your set will be the solution. That would be 1, 2, 3, 4, 5, 6, 8. There. And the last one, this tells us, well, it's asking us, where do the three sets intersect? And that is only in the middle here. So that's the common element between all of the three sets. So your answer there is only one element, which will be 4. This example 22, we have a universe which is all of the positive integers. Okay, so that would be 1, 2, 3 to infinity. Okay, so basically the natural numbers. Set A, we write the elements 3x, such that 3x is less than 30. So let's think about A, we'll do it here. We have 1, so 3 ones are 3. Is 3 less than 30? Yes. So we write 3. If x is 2, 3 2s are 6, and 6 is less than 30, and we write the number 3 times 2. So 6. If x is 3, 3 3s are 9. So we're basically writing the multiples of 3. So we'll go 3, 6, 9, 12, 15, 18, 21, 24, 27. And we don't go up to 30 because this says less than 30. So this is really just the multiples of 3. Set B, if x is 1, 4 ones are 4, and that's less than 30, good. So we write the number 4x. So that means we write 4 as the first number. If x is 2, 4 2s are 8. 8 is less than 30. So we write the number 4 times 2, which is 8. So we have 4, 8. And you can see these will be the multiples of 4, which are less than 30. So 2 4s are 8, 3 4s are 12, 4 4s are 16, 5 4s are 20, 4 6s are 24, 4 7s are 28. And we need to stop there because 4 8s are 32. So these are the two sets. We can write them here. 3 6 9 12, 15 18, 21 24, 27, and B 4 8 12 16, 20 24, 28. Okay, so look at the cardinal number of A. How many elements are there? 1 2 3 4 5 6 7 8 9. How many in set B? 1 2 3 4 5 6 7. Like that. So how many in the union? We're going to need to write them all down. So we're going to have 3 4 4 6 8 9 12 15 16 18 20 21 24 27 28. Ran out of space. Anyway, how many elements? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. 14 elements. Now, how many elements are in the intersection? So the intersection between A and B, we have 12, we have 24, but only 2. So in that case, the intersection between A and B is only 2 elements, which are 12 and 24. So that would be 2. So let's check this. The number in the union is 14. The number in A is 9. The number in B is 7. Minus the number in the intersection is 2. So 14 equals 9 plus 7 is 16 minus 2. And notice how we get 14 on both sides. Okay, now this rule here is true for every kind of set. So the number in the union is the same as the number in the individual sets minus the number in the intersection. And that works for all kinds of sets. So that's basically your rule that I've written here. and it works for all sets. And we can extend this to 3 sets. So it actually looks difficult, but it's not that hard to remember. We've got the number in the union, A union B union C, is the number in the individual sets and added. Notice that these have been added, minus each intersection in combination. So A intersect B minus A intersect C minus B intersect C. But at the end, we add the intersection in the middle of the diagram. And this also works for every kind of set question. This is very useful for some questions that you'll see later. Okay, here's a few exercises. As before, just go to shade your regions. So we can help with the first one. A union, not B. So A is here. Union with not B. So color all of not B in, like that. And union means anything. Anything that you've colored in is good. So your answer is all of this. Remember, not intersection, union. So anything altogether that you've colored is good, is part of the answer. So that would be the answer to question 1. Question 2, you're just given 2 sets. You can make a diagram if you like, but you just need to find a union of A and B. So union means everything together. So all of the numbers you find here are written here. So you're going to have 1, 3, 4, 5, 6, 7, 8. Okay, and that's the answer there. That's all you need to do. And do the same for these ones here. This is section 3.4. It's called the difference of sets, or the relative complement. So we can just call it subtraction of sets. So for example, we've got set A, removing the elements that are in set B. Or it can be written using slash here as well between A and B. So A minus B, you're in A and not in B. So we have set A here, and we remove that bit that is in B. So this bit is removed here. In this one, we have set B, removing the elements that are in set A. So this here, you can see it's the same as B only. And this one here is A only. So we have set A, 1, 2, 4, 7, 8, and set B, 2, 6, 7, 9. We can put the numbers in. Are there any overlaps? 2 and 7. So 2 and 7 must go in the intersection. A then has 1, 4, 8. And B has 2, 7, and the other numbers are 6, 9. So they go there. So this is telling you A minus B. So set A minus the elements that are in set B. So your answer for this one would only be 1, 4, 8. Because we removed the elements that were in set B. In this question, we have set B removing the elements that are in A. So these ones will get removed. So your answer will be 6, 9. Like that. So if you want to write it all out, you could have A, 1, 2, 4, 7, 8, minus 2, 6, 7, 9. but you don't really need to do that. But you see, you've got these elements, and we need to remove any element that is in A. So 2 is gone, and 7 is gone. So you're left with 1, 4, and 8 is written there. There's a few exercises to do related to this topic. So we've got set A minus the elements in set B. So you've got 1, 2, 3, 4, 5. We have 3 and 5. For A minus B, you will be left with 1, 2, and 4. Like that. And B minus A is done the same way, but in reverse. So set B has 3, 5, 7, 9. 3 and 5 again. So you would remove 3 and 5. You would be left with 7 and 9 in that question. So let's have a quick look at question 6 that you'll need to do. Remember, your universe is all of the elements together, including these ones that are outside. Okay, so you're going to have 1, 2, mark them off, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 1 to 10. I'll just do shorthand like that. So A union B, remember, is all of the elements in A and B. So your answer for this one would be everything that's colored in yellow here. So 2, 3, 4, 5, 6, 7, 8, 9 would go here. How about this one? Not A intersecting not B. Let's color in not A. Not A is here. Okay, where does that intersect not B? The color in not B. So where do they intersect? You can see it is only outside the sets, out here. Okay, so then your answer would be only 1 and 10 for that question there. So try to get lots of practice shading the area using your tablet or pencil, but then rub out the unnecessary lines. How about we practice a few more Venn diagrams so you get a bit more comfortable with that? So I've drawn one here. We have 3 sets, A, B, and C. How about we shade in A, union B, intersecting C. Now there's no brackets here, is there? So we go left to right. We go this way if there are no brackets. So A union B, what is A union B? So color in everything that is A or B, or both. So this is or, but intersection is and. So when we're doing intersections, we're looking for where our lines cross over. Or can either be this way, or this way, or both. Okay, but intersection is only where they overlap. So we've done A or B here. Where does that intersect C? C is here. Okay. So where are these two sets overlapping, A or B? Where does that intersect C? You can see that's only in this part here. Okay, where the lines overlap. So there and down into here. So if you get a question like this on the test, you should erase out your other lines because these other lines are not required. Okay, so get rid of those. And that would be your final answer there. So here's another example. A union B not or complement intersecting C. Okay, start left to right. We have a bracket here. So we've got A union B, but not that. So A union B would be all of this area here, right? A union B, but we don't want that. We want outside A union B. So we color outside A union B. Like that. So that is not A union B. A union B is in here. So not A union B, intersecting C. And C is here. So where do these intersect? Only this section here. Okay. So your final answer would be only this area here. So not A union B. Where does that touch C? Only in that area there. And again, remove your final lines. Don't remove your circle. Keep your circle in there. And that's your final answer. So have a go at the questions and send me a message if you're not sure how to do these, and I'll make some more examples.